acute angles R and P. All right, so we'll start with R. Now I'm just going to go with 6 of you, okay? So Stephen, help me out. What is the sine of R? Correct. Okay, Michael Davis, what is the cosine of R? Cheat, use the little fraction above. 17. All right, let's talk about this word adjacent. We'll do a little self-correcting. You're going to catch what I'm talking about. Right now, I am adjacent to this table. What does that mean? I am next to it, okay? So adjacent means next to. Now, you might think, hey, Coach Morgan, that doesn't make any sense because regarding the angle R, there are 2 sides that are, quote, next to it. All right, so the hypotenuse we would designate is the side that's across from which angle? The 90 degree. Angle Q. I got it. I didn't know what you had said. Yeah, it's the largest side in your right triangle. And so that's going to be our hypotenuse. Therefore, give me my fraction, Michael Davis. Beautiful. Good self-correction. 15. Say it again. No, we said hypotenuse is the largest side in a right triangle.
If we were doing like for Q.
You won't do it for the rest. Somebody asked that question last week. You don't reference, you might see in the instructions, acute angles R and P. You're not going to reference SOH CAH TOA on a right angle. I'll teach you why a little bit later on when we start talking about the unit circle and we talk about quadrantal angles. 90 degrees, we don't even mess with. Okay. Freddie, open those eyes up and tell me what you think about tangent of R. All right, so look up here. We got opposite. What side is opposite of R? And then what is your adjacent? What side? Your eyes might have been closed when we were just talking about that. What side is adjacent to R? 15. Good. So we got 8 over 15. Now, y'all are just learning this, and so I'm treating you, nice and calm and sweet and patient and all that good stuff, right? But eventually, it's grind time. And it's to where, man, I look at this and automatically, if I hear the word tangent and my eyes lock on the angle, my eyes immediately are going to go opposite, adjacent, got my fraction, dead to rights in seconds, okay? Right now, we're thinking about it, and it's totally fine. But we want our goal to be fast. And so there will be a timed, BJ, I'm going to get you in a sec. There will be a timed exercise on tonight's homework that's doing just that. It gives you a picture like this, and it's like, hey, what's the sine of P? And as fast as you can go, you want to say 15 over 17. Or if they say, hey, what's the cosine of P? 8 over 17. What's the tangent of P? 15 over 8. And it's wham, bam, thank you, ma'am. The more that we practice, the faster we'll get. So I recommend you try and lock that time down as low as you can go. I've got 60 seconds is the benchmark to get 10 of them. I think that's doable. I'll try and get it in 30 seconds. Try and get it in 20 seconds. Let's see who can be the fastest. Yes, but and so what BJ has just noted is that sine and cosine are like cousins. They are co-functions. I mean, you think about the word sine and cosine. We also have these other functions you maybe haven't learned about just yet: secant and cosecant. What else do you think there is? Tangent. Whoops. Where'd I go? Tangent and cotangent. So these are all co-functions, right, that we're going to learn about. And so these two, like BJ just said, being co-functions, what that means is that for a given right triangle, the sine of R is going to be the same thing as the cosine of P, because those two angles right there are, well, you tell me what's the relationship between R and P?
Out of 90. They're complementary.
Vocabulary word.
Complementary.
They are complementary. What does the word complementary start with?
C. O-N.
C-O. All right. So you can very, very good observation, BJ. You can real easily tell you know, if you know what the sine is and the cosine is, then you can just flip those two. So I know the sine, hello, Jack, of P. You mind asking where you've been?
Went to go. Let me call my parents.
Gotcha. If you don't have there's like a form that you guys were supposed to fill out at the beginning of the year where you get permission. Sorry that took a little while. We are recording, so it's on YouTube if you want to play catch up. We had some warm up stuff, and we're just doing SOH CAH TOA exercises now. So the sine of P, we would say, is opposite over hypotenuse. So I'm going to say 15 over 17, which, as BJ just said, you know, matches the cosine of R. And so what would y'all say that the cosine of P is? Yeah, that's the sine of R. Now, what's the tangent of P? 15 over 8. That looks like 18 over 8. 15 over 8. Oh. Okay. Finley, have you already learned this? I had some kids that told me, Coach, we learned this in physics. Yeah. We learned this in physics. And I think, man, that's fantastic. You're going to thrive because if you've already seen this stuff, you got a good foundation, we're going to roll. Like, it should be 8. My brain was thinking like I had just written 18 with that little 5 mess up there. But good catch, Blake. So easy enough. Our basic 3 trig functions. Okay. Not rocket science. Now what we're going to do is I'm actually going to give you an angle, and you've got a calculator on your desk. Yes, everybody got a calculator? Oh, and then what we're going to do is we're going to try to use some trig ratios to find x and y. I will do one. I'll set it up, and then you will do one on your own. Okay. So here we go. In blue, I like blue. Let's try and find x first. Okay. So obviously I have this angle, and I have x to find, and I know 6. So I'm going to ask Kenneth which. No, it does not matter. Does not matter. Kenneth, which trig ratio do you reckon relates 35 and x and 6? Oh. Well, let me ask you this. What is x in relation to 35? Is it opposite, adjacent, or hypotenuse? Opposite. Good. So we know which trig function's out right off the bat. Cosine's out because we know cosine doesn't use opposite. All right, now back to Kenneth. Kenneth, what is 6 in relation to 35? Adjacent. So what's our trig function that relates opposite and adjacent? Tangent. So I'm going to write up the trig expression here. We're going to say the tangent of 35 degrees equals x over 6. Now this looks like the warm-up. Okay? Now I'm going to ask a weird question. Nash, don't answer this question the way that you think you want to answer it. Answer this question the way that I'm wanting you to answer. I know that's a hard ask. What is tangent of 35? Okay, so let's pause for a sec. I've prefaced my question and got you all off. What would you have normally done had I not said anything if I'd have been like, hey, what's the tangent of 35? You'd have probably what? Yeah, you got one on your desk right there. You would have probably plugged it in and gotten a number. Okay, that's all the tangent of 35 is.
Can you explain that though? Like, I just want to curious to what it actually means as a number.
Oh, totally. Yes. Okay, so tangent 35 is first of all, in its essence, it's just a number. It's a constant. Okay, and what it is it is the ratio, no matter the size of the triangle, right? So I'm going to draw a buttload of right triangles here. Watch this, okay? Doesn't that look pretty? All these are right angles. Right angle, right angle, right angle, right angle. Okay, for each of these angles, and let's make this theta. Theta is a Greek letter that we use for angles. Have I said that before? Yes. Okay, theta is an angle that we use for letters. All right, so what is the definition of the tangent of theta? Okay, well, it's going to be the ratio for each and every one of these triangles of the opposite compared to the adjacent. Now, whether I'm talking about this itty-bitty little right triangle right there, and maybe I wanted to call that A and that B, or maybe I'm talking about this triangle right here in the middle, and I want to call that, I don't know, C and D, or maybe I'm going to talk about this big, what should we do? Orange? This big, huge, fat triangle right there, and we call that like E and F. So like regardless, let me go back to green now. Regardless, our definition is going to be A over B or C over D or E over F, right? And it's sort of like our definition of what pi is. Phil, do you remember what pi is defined as? No, so that's kind of like what I asked Nash. Don't give me 3.14. Give me like, what do you think it is in its essence? What is pi? If you don't remember, that's okay. We'll go to somebody else. All right, Christian, do you remember what pi is? Nicholas?
Circumference over diameter.
Good. It's a ratio of circumference over diameter. And it does not matter the size of the circle. You have a big old fat circle, a little bitty circle. It's always circumference over diameter. It's approximately 3.14. So similarly, and I love the question, Sebastian, similarly, what tangent is defined as, no matter what the angle is, it can be any old angle, right? It's going to be the ratio of opposite to adjacent, opposite to adjacent, opposite to adjacent. For us, we're locked in with a specific angle of 35. And so I know it is a number, and I can find that on my calculator as long as my calculator is in what? Degree mode. Now, if you've spent any time in my senior class, especially the first, you gonna leave the man hanging? I'm gonna show you. If you spent any time in my class at all, especially first semester, like seniors, if you were doing like a makeup, it's very likely that you maybe heard me because I said it 100 times, Fredo, during the first semester with my seniors. I would be like, fellas, this problem is in radians mode, but I am a degree man. And so they cottoned on to the fact that I like things in terms of degrees. And so we would be working this rando problem in our senior class. And I would be like, hey guys, this problem, what mode should it be in? And they're like, let's put it in degree mode because you're a degree man. Okay. Make sure your calculator's in the right mode. So we're going to hit the mode button. Okay. And then roll down that left-hand side. The default settings for this calculator, typically it comes out of the factory in radians mode. So you want to check to make sure, see, look, I'm a degree man. I've got my calculator in degree mode. I highly recommend that you keep it in degree mode, especially on the ACT. Please do that. I think these are all default. You hit mode and then hit mode again. So when you hit mode and then degree is 1, you just hit 1, and it usually shows like a little B up there. So I think figure it out. Mario.
Are there teachers here who want it in radian mode?
There's circumstances that want it in radian mode. So I'll tell you when I want it in radian mode. But I'm encouraging you, for the vast majority of the stuff that y'all deal with, leave it in terms of degrees. And then your teacher will, like the context of the problem dictates it, or your teacher will be like, hey, put your calculator in radian. So that being said, I can go now on my home screen and I can call up tangent. There's the tangent button, 35. And I hit enter and look, it's a number. Now it's a weird irrational number, right? It's not a nice, neat, pretty little number. I think it's actually called a transcendental number, which is always a fun vocabulary word. But what do I do with that number to get my answer? Just like in the warm-ups, we're going to multiply by 6. So just like right here in blue, we would say, hey, times both sides by 6. Now on my calculator, I can say x equals 6 tangent 35, or approximately whatever 0.7 times 6 is. 4.2. Okay, fantastic. So that's what x is. Now, I'm a big fan, fellas, of labeling. If they've got a picture, labeling the side that you're trying to find with that number. Now, I'd like you to do the same thing to find the hypotenuse. Same thing, please. Find the hypotenuse. Now, you should keep in mind that, do I once in a while make a mistake?
Yes.
That was a little too quick of an answer, okay? You should have thought about it for a moment before you jumped on it that fast. Good grief. Sometimes I make a mistake. So, Freddie, pick your head up. Should I use 4.2 in my follow-up calculation?
No.
Why not?
It's not exact.
Well, it's not exact, but also I might have made a little mistake. So what should we use? We should use the given information. Mike, last step, what is 6 as it pertains to 35 degrees? It is adjacent. And what is y? Hypotenuse. So Jack, which trig function would you like to use considering that we know the adjacent and we're looking for the hypotenuse? We should use cosine. All right. Write me up an equation, Franklin. What should it say? Cosine of what? Good. Remember, we always do, let me just pause because I'm kind of teaching basics today. We always do the trig function of an angle. Y'all remember learning about logarithms? Yes? You remember learning about radicals? Yes? Okay, I use the word in both those contexts of the argument of the function. Have you heard me say that before? Okay, so with logarithms, right, let's just take time out. If I said, I want the log base b of a equals x, right? What's the argument? Is it b, a, or x?
B, A. Did you see it?
So the word argument starts with an A. Am I being tricky or am I being helpful? What the argument is what you're taking the log of. So the argument right there, that's what's meant by the vocabulary word. You are operating that function upon a certain input. Okay, how about the cubed root? If I did y equals the cubed root of x minus 7, what's the argument there of that function? X minus 7. It's what you're operating upon. You are taking the radical of that argument. Okay, so with our trig, we always, and Franklin did a good job with this, we always take the trig function of an angle. The angle is your argument. In the second half of class today, that's going to be very important. Okay, so we've got cosine 35 equals 6 over y. And now this is going to be an opportunity, Henry, for me to use the what?
The switcheroo.
If I'm asking Henry, let Henry have the fun of saying the old switcheroo, dadgummit. All right. So to get y by itself, yes, Finley on the warm-up, we could multiply both sides by y and divide both sides by cosine of 35. Or I could just pull the old switcheroo and say y equals 6 over cosine 35. And then, as Henry said, get out my calculator and punch that in. What mode should I be in? A degree mode, because I am a degree man. Cosine 35, we get about 7 and some change, about 7.3. You get the wrong answer. Yeah, you'd have to convert it back in. If you got to go in, we're in radian mode, you would have to change 35 degrees into radians, and that's pesky. I'll teach you how to do that, but it's pesky. All right, let's see if we remember from last week some geometry facts. Okay, Alfredo, if I asked you, we didn't, but I'm just asking. If I ask you to find this angle, could you find that angle? How so?
Plus 35 plus 90 minus 180.
All right, so all three interior angles add up to 180. So that'd be like if I had $180 and I was going to give some to Sebastian, some to Andrew, and some to Aiden, right? So if I give 90 to Sebastian and I give 35 to Andrew, how much do I have left for Aiden? 55. All right, 55. May I recommend that we get really good at complementary thought? In other words, y'all told me earlier, 35 degrees is complementary to this missing angle. In your brain, you ought to almost automatically think, I wonder what the complement of that is. Because in right triangle trig, we do it all the time. Okay? BJ. Now you'll be fine. All right, so good, Fredo. You passed question test number 1. Number 2, okay. Stephen, number 2, talk to me about the triangle inequality. Does that hold? In other words, are my answers legit in that way for this? Do we remember what triangle inequality means? We talked about 3 branches of government. You remember that in the context last week? We had this up, and by the way, when I'm recording y'all's class, I can go back and be like, I did say that after all. Remember what we talked about? The sum of any 2 sides of any triangle must be greater than the third side. So like any 2 sides are going to outweigh the third side. Is that the case with my answer here? All right, that's a smart check that you can run. It doesn't take a lot of time. You can be smart about it. You say, well, let me double check here. Is 6 and 4 going to be more? Because what happens if I got an answer like 11 right here? Yeah, I've done messed up now. What y'all doing? Why y'all? Dude, if I taught at St. Agnes, this would be one thing. Little girls putting lotion and stuff on their hands. You got hand sanitizer, you got Vaseline. You're all lubed up and ready to go. Congratulations. Pause.
There you go.
Boy. All right, Finley, help me out then. So good job, Fredo. On Steve-O. Hey, right here. That's okay. Well, my third thing would be largest angle across from largest side. Did I hit it here?
Yes.
I did. Okay, biggest angle is 90, biggest side 7.3. So in other words, if I got an answer like 5 for that hypotenuse, I know that's bogus because it's got to be more than 6. Okay, Freddie, open your eyes. Tired of telling you that. You need to stand up. You need to drink some water. If you need Michael to slap you, go right ahead. One of those 3 things needs to happen.
Volunteer.
All right. Yes, sir. Everybody's exempt unless their name's Kenneth, and then Kenneth has to take 3 exams.
Isn't it 80 semesters?
Your classmates think they're so funny clapping on that. Kenneth is 80 or above all 4 quarters, and if you mess, wait, are you going to listen to the whole comment?
He's already out. He's already out. He's already out.
It's 80 or above all 4 quarters, but if you mess up one of the first 2 quarters, but you've made an 80 or above on the exam, then I forgive those first 2 quarters and just need 3 quarters, 3 quarters, 4. 80 is the lowest I can make it. The school doesn't let me make it any lower than 80. And the exam's cumulative, which is why I include all 4 quarters instead of just quarters 3 and 4. But I do give that little caveat about the first semester exam, just in case. Are you cooked? That's all right.
Raleigh.
Okay, here's an example. And I want you to write down a definition. We might have already talked about this definition, but you need to understand what it means to close your laptop, BJ. JK.
Yeah.
No, you need to know what it means to, quote, solve a triangle. Nash, what do you think solving a triangle means? Read the first line on the screen and you wouldn't.
Triangle, find all the sides.
Good. Okay, so if I asked Nicholas, if I said, Nicholas, solve this triangle, and Nicholas only found the sides for me, he has not solved the triangle. We want to find all the sides and all the angles. All right. Just right triangle. We are studying what's called right triangle trig. When we get into the non-right triangle trig, that will be law of sines, law of cosines, and some other nifty stuff as well.
That's why.
What is angle B? Okay, very good. You go to the restroom. How's a lot? Hey, by the way, do y'all notice how I switched the lettering on this?
Yeah.
Okay, so don't let that throw you off. Please don't let that throw you off. We want to be comfortable. Sometimes you use different letters altogether. M, N, P. Delta Math likes to use that. Or we might use letters X, Y, Z. You gonna wear the button on that calculator I'll let you borrow? What are you doing?
I'm -3.
Successively? How about a -3 from your grade? Do y'all's other teachers like to be sassy like I do?
Coach Scott did one time. We got really mad.
Coach Brian Scott or Art Scott?
I just put a 0 in there.
Everybody.
Ouch. Did he do it?
No, couldn't make it far enough, so we got.
Which one?
In geometry, when we did angles, we did like CBN, angle CBN. We don't have to do anything.
You'll see that on the ACT or the Delta Math or in class, but I don't force it either way. Typically, what I'll call it is I'll say this is angle A, this is angle B. Like what's his face? Michael told me angle B. Did y'all hear what he said? Angle B is 70 degrees. Again, that's because we know all 3 angles add up to 180. All right, that's the low-hanging fruit. That's the easy thing. Do that first. You know, Aiden, what would you like to find? You want to find A or B? Little A or little B?
Yeah.
All right, good. We'll find little b. So think about it like this. Little b, 9 is given and 20 is given. It's best practice to use given information. I don't disagree with Michael that little or big B is 70, but just in case, BJ, please get off the phone or your watch, whatever you call it. Okay, so actually, BJ, help me out. Which trig function would you like to use? All right, so we'll do the tangent 20. Sebastian equals what over what? 9 over B. Henry, we can pull the old switcheroo. So I got B equals 9 over the tangent of 20. At this point, I'm bored. Plug it in. Then you've got it on your calculator.
I would do tangent of them.
Yes. Yes. All right. So we did 9 over tangent of 20. What mode am I in?
Degree mode.
Degree mode. That's right. And so what Mario is saying, what if I did the tangent of 70 is B over 9, and I said 9 times the tangent of 70? You get that same value. Okay. So whatever floats your boat. Now, at this point, okay, so what was it? What did we get? 24.7? You guys concur with that? All right. By the way, is that degrees or radians? Ha! Tricked you. It's neither. It's little b is a side. Right? So it's just some unknown unit. It's the length of the side. Blake. What do the instructions say? Solve the triangle. They don't give any instructions. Okay, so let's just make a general rule of thumb. Okay? General rule of thumb. This is like, you may or may not know this. When driving in Jackson, Tennessee, unless otherwise posted, the speed limit is, let's say 40 miles an hour. Okay? And so there's a law on the books in Jackson, Tennessee, because I see a sign all the time when I'm going to my in-laws' house that says, unless otherwise posted, speed limit is 40 miles an hour. And so that way, it's like you're always just assuming, oh, it's 40 unless I'm allowed to go higher. So for us, let's make an assumption. Unless otherwise noted, for angles and sides, I like the 10th place, and that's appropriate. Nicholas, open your eyes. The 10th place, everybody good with that? Which place?
10.
The 10th place. Good. Now, I have a tricky question to ask you. Is there a way, Finley, you really do need to stop that. You're driving me crazy. I know you're just playing, but stop it. Is there a way other than using SOH CAH TOA that you could find little a?
Yeah. Pythagorean Theorem.
We could use Pythagorean Theorem.
Yeah.
Should we? Why not?
That's good.
Because 24.7 is an approximation. And although we would get a pretty decent answer, assuming we didn't screw the pooch for 24.7, it's still an approximation. And so I recommend that you don't round it early in the problem. Okay. Right. So like, let's say Mario and I are out playing golf. All right. Mario, would you rather misalign your driver or your pitching wedge? 100% your driver, because your driver goes a lot farther. So like, let's say over here on this sideboard that here's Mario, here's his line that he should be aiming for. There's the hole right there. And Mario is like 300 yards out and he hits his driver offline just a little bit, right? Okay. It's still going to be a lot further away because it's his dadgum driver. And so the farther that quote hypotenuse would go, then the longer that opposite side would be. And so even just a little bitty angle down here is going to make his deviation. The same thing is true with rounding. If you round earlier in a problem, like let's say in this scenario, he's right here and he messed up by the same angle, you know, this distance is a lot less. His mess up is a lot less hitting his pitching wedge. So round later in the problem, don't round earlier in the problem. Okay. And so here we go. I'm now trying to find little a. I'm trying to find a little a. Blake, tell me which trig function you want to use to find little a. All right, pretend like 70. I know it's correct, but do what? No. I know 70 is correct, but since I wrote it by hand, I don't want to use it. To pretend I want to use 20 again. Which trig function would relate? Kenneth, if I'm asking Blake, let Blake answer. So good. So we got the sine of 20 equals 9 over little a. And therefore, we could do the old switcheroo. Little a equals 9 over the sine of 20. And now I'm rounding at the end of the problem. And what do we wind up with? 26.3.
No, no.
26.3.
Way greater than one side.
You are tripping.
You're tripping on it.
You're some old hippie, I guess. So 24 and 9 are more than 26. 26 and 9 are more than 24. 26 and 24 are more than 9. So your triangle inequality holds. Is the biggest angle across from the biggest side? Yes. Now check this out. This is pretty good. 70 degrees is a lot closer to 20, to 90 than it is to 20. Therefore, 70's opposite side, little b, is going to be a lot closer to little a than it is to little c. Okay, does that make logical sense here?
Yeah.
So because 70 is a bigger angle, its opposite side, sort of its matching side, is going to be closer to the hypotenuse than it is to the other side, to the other leg. Okay, that should make logical sense. All right, that's right triangle trig in a nutshell. You're welcome. That's SOH CAH TOA. There we go. Now, we're going to flip that coin over, and we're going to talk about inverse trig functions. This is not as complicated as it might look. I've got a buttload of stuff up on the screen. Let's talk turkey just for a sec. Alfredo, I'll take out my wallet. I'm going to give you $5. And hey, Alfredo, can I have $5? That's plus minus inverse ops. Michael Davis, I'm going to take the number of bracelets that you're wearing. I'm going to multiply it by 3. And then I'm going to take that number and I'm going to divide it by 3. He's back to where he started. Okay, multiply, divide. Sebastian, I'm going to take the number of calculators sitting on your desk. And I'm going to cube that number. And then I'm going to take the new number and I'm going to take the cube root. Again, inverse ops. Finland, I'm going to take the amount of water in your vessel right here, and I'm going to exponentiate it. I'm going to make 2 to the power of however much that water is. What would I do to inverse exponent function? No, that was Sebastian's example. Good, Freddie. Logarithm. So we've learned add, subtract, multiply, divide, radical and power, exponentiation and logarithm. Now we're going to come over here to Nash and we're going to say, hey, I've got the sine of an angle equals my ratio. Now we're going to use the inverse sine of my ratio to equal an angle. Okay. Now with my senior trig class, like I said earlier, I spent a lot of time sort of repeating particular mantras. So I'm going to share with you one of these mantras that we repeat over and over again. I want you to listen to it. I want you to write it down. I want you to plant it in your brain. To find an angle, use inverse trig functions. To find an angle, use inverse trig functions. I've got it in bold up here on the screen with a little star around it. Okay. To find an angle, use inverse trig functions. Mario. Correct. Okay, so let's take a gander, and I'll do one on the big screen, but since I've got a lot of nice notes up there for y'all to copy down, I'll do my little sidebar example over here. Suppose that I've got ye old 3, 4, 5. What type of triangle is that? What type of triangle? Oh, somebody said a right triangle. Very good. Okay, so there's my right triangle. I know it's right triangle because 3 squared plus 4 squared equals 5 squared. There we go. This is Pythagorean, the converse of the Pythagorean theorem. We know it's a right triangle. All right. Suppose I want to find the angle over here that's across from 3. Right? What I could say is I could say, oh, just use the inverse sine of 3/5, or use the inverse cosine of 4/5, or use the inverse tangent of 3/4. Right? So any of those 3 will get you your answer for that angle. And whatever floats your boat. You know, if it's an example like this where it's a 3, 4, 5, well, heck, I mean, we could do literally any of the 3. But maybe I didn't give you the 3. Maybe I only gave you the 4 and the 5. Now you're going to use cosine. You're going to use inverse cosine. BJ? All right, making okay sense so far?
Yes, I don't think anything in the right.
Okay, so good. Let's talk turkey here. Now, with Alfredo's example of plus minus, were there any restrictions? It looks like from Gatorade. Put it up, say play. With Michael's example, Michael, what was I doing with you? Multiply, divide. With multiplying and dividing, what's the restriction? Good, Kenneth, thank you. Don't divide by 0. With Sebastian's example, let's just say squaring and square rooting. Yeah, unless you're going into complex analysis, which this is very much not, you can't take the square root of a negative number. With logarithms, we know you can't take the log of a negative number. You can't take the log of 0, and your base has to be between 0 and 1 or greater than 1. So there's certain restrictions to some of these inverse operations that we've learned about. Okay, Mitchell, wake up. You did inverse sine of 3/5 and got 36. Does anybody concur with that? Anybody run those numbers? Okay, so let's talk about where you find that inverse sine. Here it is. And I'm going to get back to my, don't let me forget, Sebastian, the word restrictions. Remind me about restrictions. So the way that you find it is, and I know this is an old calculator picture, but you just hit second and then sine or second cosine, second tangent. You can see it up above there. And there's a bit of an antiquated notation. You'll see this. Watch this. This right here, sine with a little -1. And then let's do opposite over hypotenuse equals the angle. Sometimes it's written like this, ARC SIN. That's a bit antiquated, but sometimes you'll run into it. Those mean the same thing. It's the inverse sine function, or it's sometimes referred to as arc sine, ARC-SIN. Okay, so these are the same thing. Depending on what kind of class, what kind of textbook, Aiden, pick your head up. You know, when we see these two, they mean the same thing. They're just trying to find the A. All right, Seabass. Restrictions. All right, there you go. Good. Back to Mario's question right here. So with Nash, and I've gone straight across the front, and we had all these pairs of inverse op. With this inverse operation, okay, there is a domain restriction and a range restriction. Okay. Just like you're not allowed to take the square root of a negative number, just like you're not allowed to take the log of 0, for instance, okay, your inverse sine function is restricted. Okay. Your inverse sine function is restricted. That opposite over hypotenuse has to be less than or equal to 1. Okay. I can't take the inverse sine of something that's bigger than 1 or less than -1. I'll show you. Watch what happens. On my calculator, if I went inverse sine of 1.1, even something that's just a little bit more than 1, I'm going to get an error message. Okay, domain error message. So the inverse functions are restricted, okay, so that you can't take the arc sine or arc cosine or arc tangent of something that's bigger than 1 or less than -1. And I think I've got time to discuss why. Do what? Perfect, thank you. The y is, it's going to go in the Wayback Machine. And I hope that you guys are locked in and ready to do some good learning here. But do you remember how we said find the inverse? Let's do this. F of x. Actually, no. Look, you know what? I've got one already prefabbed written right up here. There. Okay. Look at number 1. Find F inverse. Take you 30 seconds. See if you can find F inverse. Do we remember those, Andrew? Do we remember those same 2 steps? Andrew.
Like y. The x equals y.
Good. Switch x, y, solve the new y. And I'm glad you remember. Switch x, y, solve the new y. So do that real quick, 30 seconds. Switch x and y, solve the new y. And Michael Davis might say, well, wait a minute, Coach Morgan, I don't see a y up there. What's f of x synonymous with? There we go. Good. Switch x, y, solve the new y. I think I told you this before class while y'all are working. I posted a big problem set is due Wednesday morning. A homework on Delta Math is due Wednesday morning. And I posted problem set 42, and it's due Friday as usual. I think I gave you all a break last week again. Is that right?
Yeah.
Okay. So back on the wagon now. Problem set 42 is due Friday. So let's see here. We got y equals x squared plus 5. So x equals y squared plus 5. What'd y'all do to get y by itself? X minus 5. And then square root. Uh-oh. Okay. Now, what if I graphed out, Franklin, what's the shape of f of x? X squared plus 5. What kind of shape is that? Do you remember? Blake? Parabola? Okay, good. So what's the problem with graphing out a parabola? 1, 2, 3, 4, 5. There it is. Okay, so the square root function is non-negative. There's this implied domain and range restriction already on this, but more graphically, that parabola doesn't pass the what? Doesn't pass the horizontal line test. Now look, this is where we're starting to separate the wheat from the chaff. We're starting to separate the sheep from the goats, the men from the boys, whatever expression you want to use. Okay, at this point in the year, we're going to start having Kenneth Piquetta. We're going to start having to have some recall. Mitchell, you're doing well on your recall today. I'm proud to hear that. Okay, so it doesn't pass the horizontal line test, meaning it's not blank to blank. Not one-to-one. Good, Mario. It's not one-to-one. A function must be one-to-one in order to be invertible. And so as it stands right here, f of x equals x squared plus 5 is not invertible. We need to restrict its domain. We need to say, hold on a second there, boss. X has to be greater than or equal to 0. In other words, chop off that half. Is this ringing a bell? Oh, so now it passes my horizontal line test. Now it is invertible. And therefore, this function down here, oh, by the way, guess what? His range matches. This should all be some exam review for us. His range matches the domain. So the range of your inverse is the domain of your function, and the range of your function is the domain of your inverse. Those two go hand in hand. So this graph be up and to the right. Now, who remembers what they're symmetrical about? The line y equals x, right? And if I gave you a point A, B on the function, BA is on its inverse. All of that is from a few chapters back, man, maybe even in like November or December. It's been a minute. Can't forget it though. Okay. Now, the reason I'm pitching that to you here, okay, can I slide back down? All right. The reason I'm pitching that to you here is that the sine function and the cosine function and the tangent function, they have some restrictions. Okay. For y equals the sine of x, his domain is all real numbers, but his range is between, I need to use brackets, is between -1 and +1. So when we switch up and we've got y equals the arc sine or the inverse sine, what do you think his domain is going to be? From -1 to +1. And what do you think his range is going to be? Negative infinity to positive infinity. I worked really hard back in whatever it was, November, December, to teach you about, like, I physically, my hands were doing this a lot, you know, because it's important when we get to stuff like these new pairs of inverse opposites. It wasn't a big deal with Fredo and with Michael, and it was kind of with Sebastian's, and it was kind of with Billy. It dadgum is over here with Nash. So with these trig functions and their inverses, you've got to understand this domain restriction is because of the range restriction of your sine function. Now you might say, well, where in gosh darn does the restriction to the sine range come from? What is sine defined as? Fraction. Opposite over hypotenuse. And what do you know about the opposite when compared to the hypotenuse? It's always less. And therefore, Nicholas Efkeman, how would you describe a fraction whose top is always less than its bottom? Yeah. Be better than that. No, very proper. Its top is less than its bottom. It's going to be between -1 and 1. any fraction whose top is less than its bottom, and as BJ said, opposite's going to be less than hypotenuse, there's an implied range restriction there. And it's saying, hey, you'll never have a fraction opposite being more than hypotenuse. Therefore, the sine function has that range restriction of the overall ratio is going to be between -1 and +1. And therefore, the domain right here is restricted. We'll look at this more when we start graphing out sine waves, okay? But for right now, don't you dare let me catch you on a calculator trying to punch in the sine of some number that's more than 1. Excuse me, the inverse sine of some number that's more than 1. It ain't going to work that way, okay? So that in a nutshell, a rather large and complicated nutshell, is what all this right-hand side stuff is talking about. Okay. Now let's distill it down to an easy to work example, and this will be what we end with. Okay. I want to see who can find X and who can find Y. Please and thank you. I'll give you 45 seconds. I want you to find angle B. Big B is X degrees, and big A is Y degrees. We're trying to figure out what is X and what is Y. Remember, when you're looking for an angle, use an inverse trig function. Inverse trig function. Denegri, which one you finding first? That's okay. We'll pick one. You want to find X or Y? All right, let's find X. Good. Now, given that Andrew has said, Coach Moore, we want to find X, Stephen, I've got 23 and 31 are the two given sides. Do I need to fiddle fart around with finding the hypotenuse here? No, I don't. I could if I wanted to using Pythagorean Theorem. That's all right. I could, but I don't need to. Now, Michael, Esteb, which trig function would you recommend using? Good. So I got the tangent of X equals 23 over 31. That's opposite over adjacent. And so now I'm going to say what? Don't say negative tangent. Inverse tangent or arctan, inverse tangent or arctangent of 23 over 31. And then what do I like to round to? About 10th place is perfectly fine. What do y'all got on that? Anybody concur? Inverse tangent. What mode should I be in? Degree mode. Okay. I know I sound like a broken record, but it's really important, fellas. We got to have that kind of stuff locked down. 36.6, I'd round 36.6 degrees. Now, Eli, given that I'm uber confident that little x is 36.6 and I'm almost out of time, don't rerun, but use your geometry back to tell me what's little a, or excuse me, big A, little y. Think complementary. Beautiful. 53.4 degrees because they're complementary. 36.6. And we could, of course, check that by doing the inverse tangent of what?
31.
Good. And is this jiving those of you that had physics, you juniors, I think, maybe took physics with freshmen? Is this kind of in line with what y'all learned back then?
Yeah.
All right. Well, good job today. We got deep into the weeds. And what we'll do is we'll work more. I think I've got one more example. Get the homework done. I think there's a couple of us that need to do a homework assignment that we're missing. I put in a couple zeros this morning, so make sure we take care of those. Delta math from last week. I looked this morning and didn't have it done. So get it done. Some of them were incomplete. I don't know. Maybe some folks didn't finish it, but just look online. I've updated some grades and live Jesus in our hearts.
I have a question. Is work sign kind of like